So continuing our linear equation journey, we've learned about graphing and slope-intercept and standard form. We've talked about horizontal lines and vertical lines. So again, we're going to step right back into a little bit of what we have already previously talked about, and we're going to step back into slope. Oops, I got this at the end of it. So let's talk back about slope a little bit. I mean, you've already seen some of it. So usually in class, I have you guys tell me what you remember about slope. So hopefully some of you remember some things from slope, like, you know, that the letter M represents slope. We know that slope can move us up and down for the top number, left and right for the bottom number. It moves up if the top number is positive. It moves down if the top number is negative. It moves to the right if the bottom number is positive. It moves to the left if the bottom number is negative. So we talked about all that, but I want to see what you remember about slope some more. And usually when I ask this question also, I usually say, what is slope? And I always have lots of people that say, y equals mx plus b, Mr. Armstrong. And I'm like, y equals mx plus b, that is the equation of a line. It does have the variable for slope in it, but that is not what slope is. Slope intercept, y equals mx plus b, is the equation of a line. It's not slope. So what is slope? Hopefully some of you remember that slope is rise over run. Okay? And that there's a formula. Okay? That formula, most of you, this is the formula that's in your algebra textbooks. Okay? That's the official formula for it, but it also works if you do y1 minus y2 divided by x1 minus x2. Okay, so it's the same thing. So here's that up and down that we talked about all over the left and right movement. We talked about with slope. You know, just some other things. Some people, you know, when it comes to this formula, remembering slope, I got a great analogy months ago, that they call this martini glasses over a picnic table. That's how they remember slope. Because the y values look like martini glasses. And then the x values are the legs of the table. So someone says the martini glasses over, or martini glasses on a table. Okay, that's how they remember that it's always y over x, because that's one of the big problems that we run into with slope, is that someone, and it doesn't fail every semester I do this, someone's going to put the x values being subtracted on top and the y values on the bottom. Okay, even though we know that it's rise over run, and that rise means it should be the y values over the x values. Okay. Also know that when you run these, make sure that you are consistent. If you start with y2 on the top, you start with x2 on the bottom. If you start with y1 on the top, you start with x1 on the bottom. You need to make sure that you're consistent. Okay. Some other ones that you probably didn't know, that sometimes we call it delta y over delta x. This is the Greek symbol delta. It means change. Okay, the change in y, which is why there's subtraction, over the change in x. Change is another word for subtraction. So these are also two other ways that we can think about slope. All these mean slope. And again, there's that variable right there that we talk about for representing slope. So anytime you see the variable m, most likely it means slope. Okay? Now some other things. There are different types of slopes. There are actually 4 different types of slopes. Let's show you. Oh, just last thing about these. Because these are written as fractions, it's important that you always know that slope is always a fraction, even when we have just a number for the slope. Okay? This is a fraction because this number is over the number 1. So even when your slope is just a number like 2, that 2 is really still a fraction. It's 2 over 1. If you have negative 7, that negative 7 is still a fraction. It's negative 7 over 1. Okay, so slope is always a fraction, and the reason why it's a fraction is because it has to give us our directions. Remember, slope tells us how to move up and down and left and right. Okay, and always make sure that your fraction is reduced. We do not like unreduced slopes. Okay, so let that calculator using that alpha y equals help you out with reducing slopes. Okay, now going back again, there are 4 different types of slopes. Oops, jumping back up. 4 different types of slopes. Oh, there's that example. 2 is really 2 over 1. So here are those 4 different types of slopes. Okay. So this is what we would call a positive slope, because think about this like a roller coaster. You're going up the roller coaster hill from left to right. So you're really excited about the roller coaster. And you're like, yes, this is going to be the best roller coaster ever. So that's a positive slope whenever you're going up from left to right. And then this guy right here, when we are going down from left to right, that's what we call the negative slope, because this is when you've gotten over the top and you're on the way down on the roller coaster and you're like, oh my God, I'm going to vomit. This was a bad idea. Okay. So when you're going down the hill on the roller coaster, although that's usually the best part, but when you're going down, that's usually some people have negative thoughts. So hence think about it like a negative slope. So when your line is going upward from left to right, it's positive. When your line is going downward from left to right, it is negative. These 2 over here are horizontal and vertical lines. All horizontal lines, you need to know this, no matter what, have a slope of 0. Because what's happening is your y values, when you subtract them on top, become 0. And 0 divided by any number is always 0. So all horizontal lines, no matter what horizontal line it is, so like y equal 5, y equal 10, y equal negative 1 million, they all have a slope of 0, no matter what the horizontal line equation is. Slope is 0. So if slope is 0, what is the vertical line? That's right, you guessed it, undefined. Okay? Vertical lines are undefined. Reason being, because in this, your x values are the same, which becomes 0 in the denominator. And if you go to your calculator doesn't like dividing by 0, and it will even tell you so. Look, error, divide by 0. So if you get an error that says divide by 0, that means your slope is undefined. Okay, we do not divide by 0. Okay, so this is good. 0 divided by a number 0. This is bad. A number divided by 0 is undefined for us. Okay, so we're going to be looking at slope more in depth. This is just a nice little review of things that you should know. Okay, so the big one is in this section 1.2 is they want you to be able to find slope. And you've got to be able to find slope a couple different ways. You got to be able to find slope from a graph. You got to be able to find slope from an equation, which we have already done. When you learned how to convert slope-intercept when you learned how to convert standard form into slope-intercept, you were learning how to find a slope, because in order to graph and slope-intercept, you needed to know the slope. Okay, when an equation is in slope-intercept, you know the slope. So we've already kind of hit upon that in section 1.1, but we're going to review it again in here just to make sure they'll be like, oh, that's what he was talking about. So you need to be able to do it from a graph, from an equation, which we've pretty much already done, check. You need to be able to do it from a table or when given 2 points. Okay, so we've got 4 different ways you need to be able to find slope. Given 2 points, from a graph, from a table, from an equation. Okay? So let's start getting through this. Let's start with the basics. Let's start using that formula that we have right here, these 2 guys. And again, it doesn't matter which one you use. I always do y1 minus y2, x1 minus x2, because I like to subtract from left to right. But most of you are probably going to use this one. And there's nothing wrong with it. You get the same answers either way. I'll even show you that. Okay? So here are 2 points. Let's talk through what we're dealing with here. We know that the slope formula is y2 minus y1 all over x2 minus x1. I'll go ahead and do the real algebraic definition formula, and then I'll show you Mr. Armstrong's. So what I do, remember, points are always made up of x then y. Okay? And it's always x first, then the y. They're alphabetical. I know it seems like I'm kind of telling stuff that you already know, but you'd be surprised how many people mess that up. Okay? So I'm going to take the 2.5 seconds to label these. Now, notice in my formula, I have ones and twos. How do I know which one is which up here? This point right here, 5, 3, is the first point. Thus, we call these x1, y1 because they are the first two x value and y values. Okay? Since this is the second point, we call this x2, y2. Now, there is no reason why you shouldn't mess up plugging into this. If you mess up plugging into this, you're not paying attention to what you've already labeled. Okay? So we're just going to grab numbers. So y2, that's 3. Minus, okay, the minus is from the formula. y1, that's 3. x2 is negative 1. Minus, because that's from the formula, x1 is 5. So all we need to do is subtract now. See how easy that was? Just plug in the numbers where they go. 3 minus 3 is 0. Negative 1 minus 5 is negative 6. And if you go to your calculator to reduce this, you find out that the answer is 0, and that's what we want. Okay? We want the answer of 0. Now, 0 is the only number that we really don't worry about putting over 1. Okay? But all the other answers, if your answer came out to be 7, you can call it 7 over 1. 7 and 7 over 1 are the same answer. They are both A-okay. All right? Let me show you Mr. Armstrong's way because I like to subtract from left to right. So I'm going to do y1 minus y2 all over x1 minus x2. So y1 is 3 minus y2 is 3. x1 is 5 minus my x2 is a negative 1. I want to emphasize this real quick for you because this is where a lot of people mess up. This right here is because of the formula. See the minus there? That's why this is there. This guy right here is because of the number. What most algebra students tend to do is this. They see the minus, they see the negative, they're like, oh, it's already there, and they only write it once. That is incorrect. Don't do that. You need to know that both of these symbols exist and need to be there. This is because of the formula. This is because of the number. They both need to be there. Okay? Formula, number. I cannot emphasize that enough. This little sign right here does not take place of that sign. They are both required. So what do we get? On top, we get 0. On bottom, this time we get a positive 6. So notice that when I use mine, all that it does to this is it switches the signs. Okay? If you were positive here, you became negative. If you were negative, you became positive. That's all using y1 minus y2 all over x1 minus x2 does. It switches the signs between these two fractions. That's it. Okay? So 0 over 6 becomes 0. Same exact answer. It doesn't matter which formula you use, you're going to get the same exact answer. All right, your turn. Go for it. Okay. So, because most of you like to do the y2 minus the y1, I'm going to do the y2 minus the y1. And then I will do the x1 or the x2 minus the x1, and then I'll show you my way down below that. Again, this is your x1, y1, x2, y2. See, it only took like 30 seconds to do that, or less. So y2 is negative 5, minus y1 is 2. So that's good. x2 is 8, minus, because of the formula, oh, it's negative, so I got to have a negative 3 down there. Again, going back on my rant and my soapbox, because this is not the only time where you have formulas that do this to you. You need both of these. This is the formula. This is because of the number. So in the end, what do we have? We have a negative 7 on top. And down below, you get a positive 11. And does that reduce? No. So there's that answer. All that will happen for mine is the negative 7 will become positive this time. And the 11 will become a negative when we switch and do the y1 minus y2 all over x1 minus x2. Okay? So y1 is 2. x2 is a negative 5. So you can see, as I said, this becomes a positive 7. Down below, your x1 is negative 3 minus your x2 is 8. That becomes a negative 11. Both of these are the same answer. Because remember, the negative can either go on the top, the bottom, or if you wanted to, you could write it out front and say that this is negative 7/11. All three of these are the same answer. Remember, we talked about that in section 1.1. The negative can go in the top, the bottom, or out front. All right. So there, you've done this before. That's why I'm not going to spend a lot of time on it. And you're going to get lots of practice later on. So if you feel like you need more practice on that, don't worry, you're going to get it. So now we're on the graph. Okay. So when I talk about the graph and when they give you a graph, what I'm going to ask you to do is I want you to find points you know. Okay. Find me points that you know. And what I mean by that is when you look at a graph, points that we know versus points that we don't know. Let me do this. Let's say this versus this. So graph 1, graph 2. Which one do you think is a graph of a point that we know? Graph 1 or graph 2? Hopefully you said graph 1. This is a point we know because it lies right there on the corner. And remember, these lines are going to be marked for, well, we'll know what these lines mean, okay, once it's on the graph. Okay, so this point could be the point 1, negative 1, depending on what these lines were marked as. Okay, so any time that you have a point at the corner of these little boxes in here, like this guy right here, so we know that point. That point is 1, 2, 3, 4, 5, 6, negative 7, negative 1. That's a point we know. Now this one right here, if you look at it, it looks like it's halfway between there. And you might be like, well, Mr. Armstrong, that's just halfway. And I'll be like, are you sure? Because what if this point really is like 0.499999999999999? That's not halfway, even though it's really darn close to being halfway, but that's still not halfway. Or if that point was 0.5011111111, you are more than halfway now. Okay, so this is a point that we do not know. Even though it looks like it is halfway, is it really? Maybe, but I don't know for sure. Okay, so when we deal with graphs, I always ask you to find points that you know. And when you deal with this in your assignment, they're going to give you points that you know. So if we look at this graph, let me highlight some things that we know. We know this point right here. We know this point that is right here. And I have a feeling I messed this up. Maybe. 1, 2, 3, 4, 5. Yeah, this line isn't exactly straight. This is where I always mess up on this. It's so much better in class when I can manipulate that line in front of you. Let me see if I remember how this went. Okay, I remember what the slope is for this. So let me mark some other ones. Again, this graph, this is the problem with graphing, because when you draw your own graph and things like that, none of these squares are really actually kind of square. This graph has kind of been manipulated a little bit. Okay, so these squares are not true squares, just, so you know. But points that we know, and I would have pointed out in class, we actually do know that one. We know this guy for sure. We know this one for sure. We know this guy for sure. We know this for sure. Okay, my graph gets really off when I'm down here. Okay, but if you notice, you have a total of 1, 2, 3, 4, 5, 6 points that are on this line that we know for sure. And we can label them if we wanted to. This point is 1, 2, 3, 4, 5, 6, -7. I believe that's 8. 1, 2, 3, 4, 5, 6, 7. Yeah, 8. This guy right here is -4, 6. This one right here is -1, 4. This is 2, 2. And 5, 0. And this one is 8, -2. Now, in class, what I would do is I would have you guys vote as a class, and you could vote twice. And I would see which 2 points came out with the most votes. Because in order to find slope, as you noticed, you only need 2 points. Okay? Most of the time, what happens is it becomes between 3, 4, 5, and 6 that usually get the most votes. So I'm going to choose 3 and 4. But again, it doesn't matter which ones you choose. You have 6 points to choose from. I didn't mean to get rid of that 8. You just need to pick 2. Pick 2 points. Okay? Doesn't matter which 2 you pick. I'm going to pick 3 and 4 for us. Like I said, usually I just have you guys vote as a class, but unfortunately, you're not here with me now. Or are you? All right, so enough being weird and creepy. So now you have 2 points. You got -1, 4. You've got 2, 2. Well, since you have these 2 points and you know what they are, you can go right back to what we did right over here. Or, because we are so smart and we're in college, and I know all of you know how to count, okay? We're going to make this a whole heck of a lot easier. We're going to use counting to tell us what the slope is. Because remember, slope is directions, right? So we're going to do Google Maps. And what I want you to do is you're going to pick one of these points as Google Maps finding you. So it's going to go ding. I chose this guy. I could have chose the other one, but it doesn't really matter. So you're going to do like what Pac-Man does, or like what we call taxi cab geometry, and I want you to get me to this other point, which again, as I told you in the previous section, is grandma's house. Get me to grandmother's house. Okay? And according to Pac-Man and taxi cab geometry, you can only move up and down and then left and right. Oh, sounds like slope. Rise over run. Okay? So, how do I get to grandmother's house? Well, from this point, I can go 1, 2. So I went up 2. Now you know what the top number of your fraction is. It's a positive 2 because you went up. Now we'll move 1, 2, 3 to the left. And because we moved to the left 3, that's a negative number. And then last but not least, you would just reduce that down. Okay? And does this reduce down? Nope. So you can leave it as that answer. You could put the negative in front, or you could put the negative up top. All three of these are the same exact answer. Your choice. Okay? If I went from the red dot to the blue dot, I'd get the same answer because I would have to go 1, 2. That would be down 2, which would be the negative 2. And then 1, 2, 3. To the right, which would be the positive 3. Oh, look, there's the slope that we just talked about in red. Okay? So, if you want to go through and use the formula, do it. Ain't nothing wrong with that. If you want to do a little bit faster, start counting. There you go. Get her done. Your turn, and go. Okay. So hopefully you saw that this is a point you know. This is a point you know. This graph is a little bit better than the other one. This is a point you know. This one is actually a point you know. And that one's a point you know. So I gave you 5 points to choose from. Again, when I do this in class, I have students that come up to the board. They usually pick these two to be your points. Okay. So we're going to pick the 2 middle ones here. And again, you can label them. This point right there, that is 1, 2. Sorry, 2, 1. X first, then the Y. And then the other point is negative 2, 0. And again, you can run your formula. Or let's count. Ding! You are here. Grandma is there. So we're going to go up 1, and 1, 2, 3, 4 to the right. So the slope going up 1 is a positive 1. Going to the right 4 is a positive 4. Does that reduce? Nope. There you go. If you went from the red dot to the blue dot, you would have had a negative 1 over a negative 4. And you would need to say that a negative over a negative is a positive. So you do have to reduce negative over negatives because you would have went down 1, that's a negative 1, and 1, 2, 3, 4 to the left. Okay? So know that if you have negatives over negatives, you do need to call them a positive. Okay? That is reducing. All right. So there's graphing. If you have a table, let's talk about a table. Remember that your columns, the first column is X, the second column is Y. So all they're doing is giving you a listing of points here. This first point is 1, 10. The second point is 2, 14. The third point is 3, 18. The fourth point is 4, 22. You get the picture. So a table is just a nice way of telling us, oh, these are the points we know on the line. Okay? But they just didn't give you the picture of the line. Okay? So you've got 4 points here. How many points do you need to find the equation of a line? 2. So just pick 2 of them. And it doesn't matter. Now, something I didn't tell you about over here, that I will tell you about over here. The closer your points are, the less reducing you will have to do. So if I was back here on this graph, and I chose this point and that point as my 2 points to find the slope between, I would have reducing to happen on that because those points are extremely far away. Notice these 2 points were the closest ones together. The closer you are together, the less reducing you will have to do. Like we didn't have to do any reducing here. When we chose these 2 points right here, we didn't have to do any reducing because they were the closest points together. So if I come over here in my table and I choose 1, 10 and 4, 22, I'm going to have reducing to do in the end. But if I chose 1, 10 and 2, 14, I probably won't have any reducing, if not maybe a very, very little, because these points should be right next to each other. Just to kind of give you a food for thought and a heads up on that. The closer your points are to each other, the less reducing you'll have to do. All right. Now, I'm not going to find the slope of this because we're going to be doing, well, no, let's do this. Let's find the slope. Go ahead, pause the video, do it. Find the slope. Use the points 110 and, well, actually, no, you pick 2 points and find them. I'm going to use the points 110 and 214, and we'll see whatever 2 points you pick if they match up with mine. And go. Okay. So now on here, because there really isn't an order here, I just work from the top down. So I call this x1, y1. This is my x2, y2. I could have very easily called this x2, y2, x1, y1. It does not matter. Okay, that's why my formula works both ways with y2 minus y1 divided by x2 minus x1, or y1 minus y2 divided by x2 or x1 minus x2. That's why it works. Okay, so if I find the slope, my y2 is 14 minus my y1 is 10. All over my x2 is 2 minus my x1 is 1. So 14 minus 10 is 4. 2 minus 1 is 1. So you can leave it as 4 over 1, or you can call it just 4. Both of those answers are absolutely correct. Okay? All right. So so we've done the graph. We've done the 2 points. We've done the table, which is just basically 2 points again. Now we're doing it from an equation. This is what we've already done in 1.1. So know what form you're in, and then you can figure out how to find that slope. Okay? So up here, go ahead, pause the video, give both of these a shot. Find me the slope. Okay. So up here, hopefully you notice that this is slope-intercept. Y equals mx plus b. This is the easiest form to find the slope in because the slope is m and it's right in front of x. So what is the number in front of x? Negative 2/3. Done. Okay? So if you're in slope-intercept, you're pretty much done. Just write the number down in front of x. But down here, hopefully you notice that you are in ax plus by equal to c form. This is standard form. So you could have easily converted this to slope-intercept, or this is why I tell you about the formulas. All they want is the slope. Well, remember on those notes that I gave you, the slope is the opposite of a over b. So all I got to do, I don't have to worry about doing all that converting stuff. I just need to know what's the opposite of a over b. Now your a value is 8. Your b value is negative 7. Because a is with x. There's your a. Your b is always with the y. And this is your c guy. So what is the opposite of a positive 8? A negative 8. What is my b value? A negative 7. So what does this reduce to? 8 over 7. And again, you could have solved this for y and gotten the same answer. If you converted, this is what you would see. Okay, let me hide that so I can expand. So we have 8, x minus 7y equal to 56. So if you converted, you would have subtracted the 8x, and we'd have negative 7y equal to negative 8x plus 56. Divide everybody by the negative 7. And in the end, this converts to y equals negative over a negative becomes a positive. So 8/7 x, there's the slope. And 56 divided by a negative 7 is a negative 8. So there's the equation, and that right there verifies that the slope, it is 8 over 7. Okay, so again, this is that time and place where, I would just use the formula. It's faster. Look at all this extra work I had to do to get that. And then all I had to do is really just slap negative 8 over negative 7 and say it's a positive 8/7. Your call, but I wanted to show you that information. So again, this is all stuff that we did back in 1.1. I'm just having you pull out the slope instead of making you graph. Okay? All right, last but not least, in 1.2, we're going to talk about parallel and perpendicular lines. So the symbol for parallel is right here. It looks like two lowercase l's, or it could be two capital I's. But basically, it's coming from right here in the word, those two L's there. Okay, and you know that parallel lines are two lines that don't touch. So lots of those exist in our world. You know, without parallel lines, we would be living in fun houses, because parallel lines are really what make our buildings stand and things like that. Okay, railroad tracks run on parallel lines. If we didn't have parallel lines, trains would never get anywhere and they would be crashing all the time. Okay, perpendicular lines, it's an upside down T. In perpendicular lines, what's special about those? Those are two lines that intersect each other at 90 degrees. Okay, so again, this is a little bit of geometry right there, but let's talk about this in terms of algebra. And what we want to know is what is special about parallel lines and their slopes. If I had two equations and we knew that they were parallel, what would be special about their slopes? And the same question for perpendicular. If I had two equations right here in front of you, and I told you that these two equations were perpendicular lines, what would be special about their slopes? What do you remember? Good. So, parallel means that the slopes are the same. Okay? Whatever the slope of one line is, a line that's parallel to it has to have the same slope. Okay? Perpendicular, as you can see right here, is what we call opposite reciprocals. Okay? I don't know why I put that up so high, but I guess I did. Can I move it? Nope. So perpendicular slopes are opposite reciprocals. All right? So opposite meaning that the slopes change signs. So one slope is positive, one slope is negative. Reciprocal means flip it. Okay? Flip it. I think I have some examples down here that show you. Yeah. So again, kind of looking at this, if I wanted parallel slopes, as in here, so you kind of see my little M parallel. So a slope that is parallel to 2 would be 2. It has to be the exact same. Sign for sign, number for number. If I wanted a slope that is parallel to negative 3/7, it has to also be negative 3/7. Okay? Parallel lines have the same exact slopes. Perpendicular lines, as we said, we're going to take the opposite. So the opposite of a negative is a positive. And then you're going to do the reciprocal. Reciprocal just means flip it. So the 7 goes on top, the 3 goes on bottom. And that is a perpendicular slope. Okay? The big thing about perpendicular that happens is you need to remember that there are two things you do for perpendicular. Change the sign, flip it. Change, flip. Okay? You have to do both of those. Most of the time what happens is students will tell me that the perpendicular slope down here is 3/7. So you gave me the opposite, but you didn't flip it. Or they'll tell me that it's negative 7/3. So you flipped it, but you didn't give me the opposite. Okay? You need to do both. Opposite reciprocals. Change the sign, flip it. Okay? So let's see what you learned. Here are 3 slopes. Give me the parallel slopes and the perpendicular slopes. Go. Okay. So, what this parallel slope should be all easy. Hopefully you found that this slope right here is 1/3. This slope right here is -8. This slope down here is 0 because they have to match 100%. Parallel slopes are the exact same numbers. Perpendicular now. Here we go. Perpendicular to 1/3, well, it's positive, so it has to become negative. and then we flip it. The 3 goes on top, the 1 goes on bottom. So you can call it negative 3 over 1, or it's the same thing as just saying negative 3. Okay? So all of those right there are perpendicular slopes to 1/3. Because I changed the sign and I flipped it. All right. Hopefully down here you realize that this thing is over 1. So this is negative. So over here it will become positive. The 1 on the denominator goes on top. The 8 on the bottom. See? This is positive. The other one was negative. And they are flipped. There's your perpendicular slope. If you wanted to, for the negative 8, you could have actually called this negative 8 over 1. That's a perfectly valid slope for that one as well, too. Okay? Now, the ultimate question down here for this guy. Well, think about what's going on. Remember that this 0 is over 1. Well, zeros are neither positive nor negative. Okay? So the opposite of 0 doesn't really exist. But you can flip this. And if you flip it, you get 1 over 0. What did I tell you about 0 in the denominator? Hopefully you're like, it's undefined. And I'm going to be like, you are absolutely correct. The perpendicular slope to a slope of 0, or in other words, if you think about what these are horizontal lines. What kind of line is perpendicular to a horizontal? Vertical. So all vertical lines have a slope of undefined. That's what's going on. This is a horizontal. So the only lines that are parallel to horizontal are other horizontal lines. The only lines that are perpendicular to horizontal are vertical lines. Okay? All horizontal lines have a slope of 0. All vertical lines have a slope of undefined. Okay? Because the last thing you'll see in your assignment is this. They're going to either give you 2 equations or 2 sets of points, and they want to know, are these parallel, perpendicular, or neither? So you'll find the slope for these, and then you're going to look at them and you're going to be like, are they the same? If they are, the answer is parallel. Are they opposite reciprocals? If they are, then the answer is neither. Or sorry, perpendicular. If they are not parallel and not perpendicular, the answer is neither. Okay? So if they're the same number, again, parallel. If they are opposite reciprocals, perpendicular. If they don't match either one of these, it's neither. Okay? Go ahead, pause the video, give these a shot. All right. So, up here, obviously this one's easy. This is in slope-intercept. So the slope is 2. Over here, if you did the little formula, opposite of A over B, you found out that you had 6 over 3, which is 2. So if you look at these 2 pieces, they're the same. So the answer you would select for these is parallel. Okay? They might even ask you to fill in the blank for the slopes for these. So you would say this would be line 1 and the slope is 2, line 2 and the slope is 2, and then they'd ask you parallel, perpendicular, or neither. So they might also ask you for the slopes. All right, down below, this slope right here, if you run the equation, you find out that it is, I believe, a positive 1/2. Okay? Let me double check in my mind. Yeah, positive 1/2. If you run the slope for this, you're going to end up with a negative 2. Okay? If you need me to work, I'll just work it out. Let's actually do this. 5 minus 0, because this is your x1, y1, x2, y2. So 5 minus 0 all over 0 minus a negative 10. That gives you 5/10, which is 1/2. And over here, if you take 35 minus a -9, because this is your x1, y1, x2, y2, all over -14 minus 8, you get -44 over -22. Sorry, that's not a -44 on top. That's a +44. Just kidding. I was like, that doesn't come out to a -2. And that will give you the -2. All right, so there they are worked out for you. All right, so look at these slopes. Well, they are opposites of each other. Are they reciprocals? Definitely, because this number is over 1, right? So they are opposite flipped. So that means these are perpendicular. And there you go. If this would have been a +2 over here, this one, we would have selected neither because they would not be opposite reciprocals anymore. Okay? If this was a +2, they would have been reciprocals of each other, but to be perpendicular, you would have to be opposite reciprocals. So if this was +2, they're not the same and they're not perpendicular, so we would have selected neither if this was a +2. Okay, but since they are opposite reciprocals, we select perpendicular. And that, my friends, is what section 1.2 is going to be like. Enjoy.